Finding the surface area of cones, spheres and pyramids with Tutor. Here are the beginner questions, some of the easiest questions that you're likely to find on this topic. Spheres, cones and pyramids are 3D shapes which are more complicated than cuboids and prisms. They each have their own formulas for their surface area and their volume. A sphere has one curved face, no vertices and no edges. To find the surface area, you need to know its radius, the distance from the centre to any point on its surface. In this case it would be 21 meters because it's half of the diameter, which was given as 42 meters. When you know the radius, you can use the formula which is provided to you on the formula sheet in an exam to work out the surface area of a sphere, which is 4 pi r squared. Because the shape we've been provided is half of a sphere, it's called a hemisphere, we'll need to use this formula, but we'll need to divide it by 2 or half it. So in this case we can use half of 4 pi r squared, which would be 2 pi r squared. So on our calculators, 2 times pi times 21 squared is 882 pi. It helps to keep things in terms of pi until you get to your final answer to avoid any rounding errors along the way. Lastly, when we halve the surface area of a sphere, it leaves us with the area of the base in this case, or the circular face, that hasn't yet been worked out or included. So we need to add this on, and it can be worked out just by using pi lots of r squared, which is 441 pi. Lastly, we add these two areas together to get the total surface area, which is 1323 pi, and rounded to one decimal place, 4156.3 meters squared. For a hemisphere, we used 2 pi r squared and we added on an additional pi r squared. So the shortcut would have been to use 3 lots of pi r squared at the beginning, and this would have given us our final answer straight away. Next, we need to find the surface area of the cone. You are also provided with a formula to help you do this. The formula is pi rl, and this works out the curved sloping face which wraps around the middle of the cone, shown here. R is obviously the radius, H is described as the height, whereas L represents the slant height. We've been provided with the radius, but in this case we will need to work out what L is, and because we've also been provided with the perpendicular height, we'll be able to use these to form a right angled triangle and use Pythagoras' theorem to work out the slant height. Because it's labelled as the hypotenuse, we can square the lengths, add them together, and then square root. This gives us a slant height of 13 centimeters. Now I can go ahead and use pi rl, so pi multiplied by the radius, which is 5, and then multiplied by the slant height, labelled as L, which is 13. This is 65 pi. Similar to how I needed to find the circular base of the hemisphere, I'll also need to do the same for this cone. This can be worked out and added on to give me the total surface area. So working this out would be pi times the radius squared, which is 25 pi, and adding these together gives me 90 pi, which I can round to one decimal place to leave me with 282.7 centimeters squared. I need to find the surface area of the pyramid. The surface area of a pyramid can be found by adding up the surface area of each of its faces. The difficult thing to consider here is when working out the area of the triangular faces. These are sitting at a slant, going up to a point at the top, which is the height, but the height of the actual triangle would be the slant height, which goes from the top down to the centre of the triangular face. We'll need this to find the area of the triangle, and this can be worked out by using a right angled triangle with the height of the pyramid. The height has been provided and is 55 meters. And the length going to the midpoint from the edge would be halfway of the whole length, which is 96 and is 48. Again, I can use Pythagoras' theorem to work out what this slant height is by squaring 55 and 48, adding them together and square rooting to give me 73. Now I can use half the base times the height to work out the area of one of the triangles. Half of 96 multiplied by 73 is 3,504. I can multiply this by 4 to give me the surface area of all of the triangles, 14,016. And then to finish off with, I need to find the area of the square base, which is 96 squared, or or 96 multiplied by 96, and is 9,216. These can be added together to give me the total surface area, 23,232 meters squared. On to the intermediate questions with an increase in difficulty. Find the exact surface area of the frustum. When asked to leave something in exact form, we won't have the use of a calculator. A frustum of a cone is the 3D shape which is left once you chop the top bit off the cone parallel to its circular base. The smaller cone removed is always similar to the larger original cone. So we'll be able to use the formula for the curved surface area of a cone to help us with this question. What is needed for each of the cones, the larger and the smaller one, is the slant height. This can be worked out using Pythagoras' theorem. For the larger cone, this can be worked out by squaring 4 and 12, which are the shorter sides of the triangle, adding them together and square rooting to get the hypotenuse, which is our slant height. This is the same as root 160, which can be simplified to give me 4 root 10. Now I can substitute this into pi times the radius, which is 4, times the slant height, 4 root 10. 4 times 4 is 16, lots of pi times root 10. Next, I can repeat the process with the smaller cone, which is at the top. Because these shapes are similar, it means that one is an enlargement of the other. If the height of the larger cone is 12 centimeters and the height of the smaller cone is 3 centimeters, this shows I can get from the lengths on the larger cone to the smaller cone by dividing by 4. So if the radius of the larger cone is 4 centimeters, the radius of the smaller cone would be this divided by 4, which is 1 centimeter. Now I can use Pythagoras' theorem to work out the slant height, the square root of 3 squared plus 1 squared, which is root 10, and the curved surface area of the smaller cone would be pi times the radius multiplied by the slant height worked out as root 10, which is pi root 10. Therefore, the curved surface area of the frustum can be calculated by taking 16 pi root 10 and subtracting pi root 10, leaving me with 15 pi root 10. Lastly, I need to work out the area of the circular faces and add these on. I have a larger one at the bottom and a smaller one at the top. The larger one would be pi multiplied by 4 squared, which is 16 pi, and the smaller one would be pi times 1 squared, which is just pi. Now I can add all of these components together to give me the total surface area. 15 pi root 10 plus 16 pi plus pi simplifies to give me a total of 15 pi root 10 plus 17 pi centimeters squared. For the next question, the exact total surface area of the hemisphere is 75 pi. Find the length marked x. I can use the formula which is provided for the surface area of a sphere, which is 4 pi r squared. Because we need to half this for a hemisphere and then add the circular base, which is now at the bottom, this would be the same as 2 pi r squared plus pi r squared, which simplifies to give me 3 pi r squared. So 3 lots of pi, and the radius is given as x. So multiplying this by x squared should be equal to the total surface area, which is provided as 75 pi. Because we have pi on both sides of the equation which we've now formed, we can divide by pi on both sides, which gives me 3x squared on the left side, 75 on the right hand side. Both 3 and 75 are divisible by 3, so x squared will be equal to 25. Lastly, I can square root both sides, so x would be equal to root 25, therefore leaving me with an answer of 5 centimeters. On to the advanced question, one of the trickiest questions that you're likely to find on this topic. They've told us that the surface area of the cone is equal to the surface area of the hemisphere, and we need to express h in terms of x. This means that our final answer would be expressing h with an equals, and whatever's on the right hand side or the other side will be an expression in terms of x. So could be something like 2x, for example. To do this, we'll need algebraic expressions for the surface area of the cone and the surface area of the hemisphere. Starting with the cone, I'll be able to use pi RL, but I'll need to use Pythagoras' theorem to find an expression for L, which is the slant height. This length was labelled as h, and this was labelled as x. So an expression for L can be worked out by squaring the two shorter sides. h squared and x squared, adding them together and square rooting. Using this to work out the curved surface area by substituting into pi RL. I have pi multiplied by the radius, which is x, multiplied by the slant height, which I've worked out to be root h squared plus x squared. I'll also need to add on the circular base, which is pi lots of x squared. Tidying this up would give me pi x root h squared plus x squared plus pi lots of x squared. Now I can work out the total surface area of the hemisphere. I can do this using 3 pi r squared. 3 times pi multiplied by r, which is given as x squared, which simplifies to give me 3 pi x squared. Now I've been told that the total surface area of the cone is equal to the total surface area of the hemisphere. So making these equal to each other, I have pi x multiplied by the square root of h squared plus x squared plus pi x squared is equal to 3 pi x squared. I can subtract pi x squared from both sides to start off with. So this will leave me with pi x root h squared plus x squared on the left hand side is equal to 2 lots of pi x squared on the right hand side. Now I can divide through by pi x. This leaves me with root h squared plus x squared on the left hand side and 2x on the right hand side. I'm attempting to make h the subject so that we can express h in terms of x. To do this, I'll need to square both sides to leave me with h squared plus x squared on the left, and squaring 2x would give me 4 lots of x squared. Now I can subtract x squared from both sides, so h squared is equal to 3 lots of x squared, and square rooting on both sides will leave me with h on the left hand side, and then square rooting 3x squared. The square root of 3 is root 3, and the square root of x squared is x. So my final answer is h equals root 3x. Before you go, take a look at this solution which I've provided. I've made some mistakes. See if you can tell me what they are, or make some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring.com for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.